All right. Hi, everybody. Welcome to this edition of the Wild Neighbor Speaker Series. We are really happy to have y'all here. Our speaker today is Luke Ball, who is the Fire Management Environmental Program Coordinator with Austin Water's Wildland Conservation Division. And he'll be talking about wildfire, wildlands, and you. My name is Johanna Arendt, and I am the community liaison with the Travis County Natural Resources Program. And we are collaborating with Austin Water Wildland Conservation Division to put on this webinar series as part of the Balcones Canyonlands Preserve outreach that we do. So City of Austin and Travis County co-manage the Balcones Canyonlands Preserve along with a number of other public and private partners. And this is a way that we are connecting with the community. And so if you have any other ideas for other topics that you would like to see related to the BCP, please do let us know. We'll have a live Q&A at the end of Luke's presentation. So if you have any questions for him, go ahead and put them in the Q&A box. And Jaya Torres with City of Austin is going to be facilitating that Q&A. So she'll be reading those questions to Luke at the end. So all you need to do is put them in that Q&A box. So without further ado, I'm going to stop sharing my screen and hand it over to Luke.
All right, thank you. Hope everybody can hear me. I'm going to give this presentation without being able to see the crowd, which is unusual, but bear with me. As mentioned, my name is Lucian Ball. I go by Luke, Environmental Program Coordinator for Austin Water's Wildland Conservation Division. My job with the division is fire management on the property that we are in charge of. To that end, we do fire mitigation, we do prescribed fire, and we do everything that's involved with how fire behaves on the landscape we're responsible for. What we're planning on talking about today is living near the wildlands. This is wild neighbors, or neighbors to the property, the BCP specifically. And the questions that people have a lot about wildfire relate to how they can prepare for wildfires, what they can do, and what the land managers are doing for wildfire. So we'll talk about some of that today, and at the end, we'll be able to answer any questions you've got. We'll have plenty of time for y'all to submit questions that we'll answer. So starting this thing out with a quote here from John Quincy Adams: "Patience and perseverance have a magical effect before which difficulties disappear and obstacles vanish." And I mention this because the timeline and scale and scope of the wildland fire issue in Central Texas is broader than any of us. We are in a situation where the development of the land and the natural state of the land have taken a long time to come to the status currently. And so any changes we wish to make to the landscape are going to require patience and perseverance. And so the group that we're talking about today, the land managers here, is the Balcones Canyonlands Preserve partners. These BCP partners are part of the Balcones Canyonlands Conservation Plan. BCCP was in to allow for development to occur in parts of Travis County that have endangered species habitat while still protecting that habitat. The BCCP has allowed for neighborhoods to be built, development, roads, infrastructure that we need to live in this area. And it's also a framework for multiple agencies to partner together and manage land for endangered species habitat and environmental protection together. You'll see that there are a number of partners involved in this, City of Austin and Travis County, who are represented in this webinar, as well as LCRA, City of Sunset Valley, Nature Conservancy, Audubon, and then various private preserve lands that are owned by neighborhood associations or property owners associations. So this is a interdepartmental and a intergovernmental effort that involves city, county, state, nonprofit, and private groups. So we talk a little bit about the land coverage of Travis County and how this affects you. Travis County is roughly 654,000 acres total. In Travis County, the City of Austin, as of a couple of years ago, had jurisdiction over 396,000 acres of Travis County. So the city of Austin is a big, has a large coverage in Travis County. And of the land that is in Travis County that is not fully developed, these groups we're talking about and other land management groups that aren't part of the BCCP manage roughly 66,000 acres in preserve land. So that's about 10% of the total land cover of Travis County is in some sort of resource preservation. And that's not bad. I mean, it's only 10%, but that is 10% that is intentionally and durably preserved for endangered species habitat or other natural resources. So on the Balcones Canyonlands Preserve properties, the management goal is to primarily preserve endangered species habitat by protecting closed canopy oak-juniper woodlands. This land is also responsible for protecting karst invertebrates, insects that live inside the karst caverns in the ground here. Those endangered species also benefit from protecting closed canopy oak-juniper woodlands. So what you see when you drive through western Travis County is this beautiful landscape like this, rolling hills, fully forested. That's intentional. That's the management direction that the BCP managers are intending. And that vegetation cover is what provides habitat for endangered species. But then we have to talk about fire. So fire is not, it's not a new thing. Wildland fire is not new to this area. It's something that's happened here for many years. It happened before we lived here, and it will be occurring after we're all gone. It's the nature of the place. There's reports and suggestions that Native Americans in this area would have utilized fire historically in order to change the landscape for their own needs, to affect vegetation and therefore affect all the plants and animals that use that vegetation. We really began suppressing fire when we started developing, built resources in this area we wanted to protect from fire. Certain types of agriculture, the built environment, homes, structures, fire suppression became part of our human behavior locally. So why do we have fire here? This is the fire behavior triangle. It's a it's a basic concept in wildland fire that shows why fires occur in an area. The three main factors are fuel, weather, and topography. When we say fuel in wildland fire, we're talking about anything that's available to burn. So that's going to be primarily wildland fire fuels, live and dead vegetation that's there to burn. Weather, the big weather effects that we have here are temperature, weather, relative humidity, and wind. And when it says precipitation there, that encompasses things like drought that we've experienced before that really can have a strong effect on fire behavior. And then topography is the shape and slope of the land. So when you look at this fire behavior triangle, you'll see some things here that are necessary for fire to occur that we can affect, things that we can have control or influence on, and certain other things that we have no control or influence over. So how do we control and influence the elements of the environment that we can deal with here? We can talk about vegetation. So this is where I get a little fatuous in this presentation here, but this is a vegetation effect. This is an approach we can take to making sure that we don't have that vegetation aspect, that fuel aspect in fire. That's probably not a good solution for most folks. We can affect our built environment. Here's a house that's safe from wildland fire. This is maybe not the greatest solution for most of us either. And then of course, here's an example of an area where you would be entirely safe from wildland fire. There is no risk here. But all these examples are just showing that none of these solutions are what anybody desires here. It's not what the land managers desire. It's not what the residents desire. This is not why we live in this area and why people want to build their homes in this environment. So in order to make sure that we stay safe from fire, since fire is a natural process that can and will occur here, we need to promote resilience. Resilience is a capacity of a system to absorb disturbance and still retain the same function, structure, and identity. What we're trying to do is reduce intensity and reduce impact of a wildland fire. That resilience can apply to both the community and the environment. Any size or intensity of wildfire can be a problem without resilience. The environment can be damaged, the community can be damaged by a wildfire and not be able to return to its original intent, its original state and function. So in order to build resilience in this area, we've decided that there's three things that we need to focus on: community preparedness, vegetation preparedness, and then awareness of fire risk and danger. And by combining those things, focusing on them, the intent is for us to end up with a low frequency, low impact fire regime. What we've seen in the past, the fires we've had, particularly in 2011, that were so influential on our community, that was a low frequency, high impact event in 2011. We don't have fires as frequently as they do in other parts of the country. What we saw in 2011 is when we did have that infrequent event, we had a very high impact from it to the community and to the environment, particularly out in Bastrop Forest. So the intent of resilience and how, when we build resilience, what we're trying to do is make sure that we have those low frequency fires, but they result in a low impact to our resources. So some of the approaches we're taking, the goals we've got here is to work on fuel mitigation. That's changing the arrangement or load of fuel, vegetation, burnable vegetation. We also do some of that through prescribed burning, which is a technique we can apply to larger areas that can affect the fuel load and the future fuel arrangement there. We do pre-suppression planning, which is to make sure that the land managers, the neighbors, and fire suppression professionals are all prepared for a fire that might happen. And part of that is going to be outreach to the public and to elected officials and other agencies that can support this effort. And we join with them in partnerships to make sure that the things we're doing are focused and collaborative. And then lastly, on here, we've got research and monitoring. That fire triangle tells us when fires are happening. The research and monitoring tells us when we're in those conditions where fire can't happen. So when we talk about areas where the risk is greatest to both the built and natural environment, we're talking about wildland urban interface areas. That acronym WUI will be used quite frequently around here. And what this is referring to is an area where structures and other human development meet or intermingle with natural vegetations. Now, one of the definitions of this is it's not necessarily the location, it's the condition. Fire occurrences in other parts of the country, fire research has shown that that the effect that a wildland fire can have on the built environment can extend farther than just the direct interface between the wildlands and the structures. So any place where fire can affect human development structures is considered the wildland urban interface. So the BCP approach is going to be wildland urban interface mitigation. We do mechanical direct treatment of areas to change the structure and arrangement and loading of fuels in those WUI areas. We also engage in habitat enhancement. By that we mean activities that will increase the resilience of the wildland to fire. and move that fire regime to a low intensity, low impact fire. When we talk about the mechanical fuel treatments that we do, the direct fuel treatments in the WUI area, typically we're talking about shaded fuel breaks. That's the definition of a type of treatment that allows us to change the potential fire behavior in an area, change the fire intensity, rate of spread, and impact in a targeted area, but still maintain the natural function that landscape gives you in that area. Shaded fuel breaks are what we consider here to be a better choice than a clear cut, because those shaded fuel breaks leave the canopy of the trees there and instead remove the lower vegetation, what we call a ladder fuel that allows a fire to spread vertically in the environment, in the vegetation. And by leaving that canopy over the top, we maintain a microclimate. Under the shade of the trees, under the canopy, there's going to be higher humidity, lower temperatures, both things that affect the fire triangle, the weather side of that. We're limiting fuel growth. Less vegetation will grow in a shady area. Under a shaded area, you'll see that the grass is shorter, less things grow. That affects the fuel growth there and affects the fuel loading. They do these type of things. Shaded fuel breaks are things that look like the shaded fuel breaks we create do occur naturally in the environment. You'll see that if in a deep, well canopied mature forest in the preserve areas, you'll see that that the fuels on the ground, the lower growing branches and ground plants have been naturally reduced by a full closed canopy. So we're working in areas where that already exists, and we're working on areas on the boundary to create and improve that type of shaded fuel break. Since you don't have to clear all of the vegetation there, there's not as much work as a clear cut. You don't have to remove as much material. And once it's established, it maintains itself for many years without additional treatment. A lot of people think we've got a risk from fire in the forest behind our house. We should clear that area. We should clear all the vegetation. What we find though is that if you cut all the trees, you completely change the vegetation structure in that area, and what you grow in that instead of those trees is grass. And grass is the number one initiator and carrier of fire, wildland fire in this area. Grass is much easier to ignite than a tree, and fire moves readily through grasses. Grasses are essentially available to burn almost any time in Texas, depending on humidity and wind and heat, whereas the forest is relatively resistant to fire occurrence, except under exceptional circumstances. So by maintaining that forested canopy there, we prevent the grass from growing, we prevent the spread and carrier of the fire from happening in that area. We keep a cool, moist climate under those trees, and we also allow access to that area. So a fire that does spread into an area with low intensity is going to be able to be suppressed by a suppression agency much more readily if they can move through that area freely. So from the built environment side, the structural side of the fence, most of the advice that we give to people and most of the guidance that the neighbors conform to is home hardening and defensible space. There'll be more information and some links at the end of this presentation for some national guides and programs that will help people to decide how to harden their home and provide defensible space. But this is a great return on your investment for fire mitigation in a neighborhood or an individual home by making sure that your home is not susceptible to fire and making sure that the area immediately around your home is defensible. You can provide much greater protection for the home from a wildfire and much greater success for fire suppression agencies that come to help you with a fire at your home. So we also engage in pre-suppression planning. When we talk about wildfire response, we have good fire protection, good fire departments here, but they do have their limitations. So in case of a significant wildfire, there's going to be a real stress on fire suppression. So in order to be most effective and efficient with the fire suppression resources we have, we're doing pre-suppression planning. We're trying to figure out where and when a fire is most likely to occur and take steps ahead of time, prepare for that. What you see in this slide is some risk assessment materials that come out of, on the left, the National Fire Danger Rating System that tells us on a daily basis what the fire danger actually is in different parts of the country. And then on the right there is a matrix we use to decide when the information we get from the national outlooks would result in an actual higher risk here locally. And so part of that pre-suppression planning is contingency planning. This is a map of one of the Austin BCP properties. These maps were produced in order to aid fire departments in response. There's a set of maps that we developed that shows the fuel, the relative fire risk, access points, routes, and hazards on that property so that the fire department can best respond to and safely suppress a fire efficiently if it occurs in this particular area. And then we also conduct research and monitoring. On the left there, you'll see someone who's collecting samples of juniper leaves. This is done every 2 weeks on our property so that we can measure the moisture content in the juniper. And it helps inform us of the fire risk that juniper might pose in case of a wildfire. We track that, and we've kept a log of those juniper moistures so that we understand what the risk is to the vegetation in case of a wildfire locally. This is what we found from monitoring the juniper moistures over every 2 weeks, and in this case is an 8-year stretch between 2017 or 2007 and 2015. This monitoring has continued, but this is the fuel moisture in the junipers, and we know that the fuel moisture goes up in the spring, it goes down in the summer, and then stays pretty low through the winter every year. But by tracking this information, we can see any trends that might occur. And something you might notice there is, toward the middle of the graph, that's September of 2011. That huge dip in the moisture levels corresponded with the damaging wildfires we had here locally. So you can see that trend moving down all through the year in 2011 and culminating in a situation where we actually had a major fire occurrence. By continuing to track this information, we're able to look for those signals, to look for those trends again in the future, and be prepared for the fire before it occurs. An interesting anecdote about that time was that in Bastrop County, the fire management professionals out there are also tracking fire danger indices and using their own systems for determining fire risk on a day-to-day basis. They knew that Labor Day 2011, things were not looking good for fire danger, so much so that the county had already activated and staffed its emergency response center before the Bastrop wildfire was reported. Their intelligence showed them that a fire was likely to occur and likely to be a major event. And so they were already preparing their emergency response center before that fire actually started, because they knew that it was imminent. So this line here on the graph is 100% live fuel moisture. Not to digress too much, but the live fuel moisture percentages that we talk about here is the weight of water in the sample expressed as a percentage of the weight of woody material in the sample. So at 100%, that juniper leaf has just as much water as it does leaf material in it. In the spring, you'll see a lot of those numbers go well up over 100%. That's because those juniper leaves are drawing moisture out of the ground. They're plump, they're full of water, they're very verdant, and they've got more water in them than they do plant material. And under those circumstances, over 100% leaf moisture, our experience in prescribed burns is that juniper are very unlikely to combust at that point. Those trees are very hard to ignite when they're over 100% moisture. Below 100% moisture, we start to see more potential for juniper trees to burn in a wildfire. And we've also found that below 80% moisture level, those leaves are dry, those trees are dry, and they're very available to burn. You'll see that in 2011, September, the lowest record we've ever had. And when we did have a fire, those juniper trees and other living trees in the forest were available to burn. The good news is, at least over this sample here for 7-8 years, those high risk, what we consider extremely volatile conditions, only occurred 6.5% of the time. So by tracking this, by knowing when we're in or approaching that 6.5% of any given year, we can make better decisions about how to pre-plan and how to respond to a fire. And so lastly is public outreach. All of this is that we do in the woods doesn't really have much effect if the public is not engaged. It's a partnership. We can do everything within our power to plan, prepare, and mitigate for fires, but we can't provide 100% risk reduction. We can't provide as much protection to the public by ourselves without public participation. So that outreach involves trying to make sure people know when the fuels conditions and weather conditions are right for a wildfire, and then making sure the public is aware of special conditions that might exacerbate things like fireworks, events, very busy holiday weekends. There just tend to be more fires during those times when people are active outdoors, and those are times when the public's actions can actually affect the result of fire, where the public can help us be resilient by trying to keep those fires to low frequency and low intensity. So I'll take any questions now. My email is here if anybody wants to email me offline, but I think for now we've got time for some questions. And then at the very end, we can put up a list of links for y'all to make notes on for more information about how to improve your homes, how to get more information about the properties that we manage.
Great, thanks, Luke. So I got a couple questions. First question, could you clarify, should the understory be removed from the entire forest or just in the shaded fuel breaks?
So what we found is that making those shaded fuel breaks are really most effective at a transition from one type of vegetation to another. And so the reason we apply them around the boundaries, typically with neighborhoods, is that a lot of homes have already got, don't have a lot of ladder fuels in their own yard. They've got grasses. We're doing some of this along roadways where there's mowed grass on the roadside. Shaded fuel breaks are most effective at preventing a fire from transitioning from a surface fire, grass fire moving along the ground, transitioning up into a canopy fire in the tops of the trees. So shaded fuel breaks are, in my opinion, most effective on the boundaries where there's a transition from one type of fuel to another. As far as the entirety of the forest, that's where general forest health treatments and making sure the forests are healthy and resilient and not overloaded with vegetation would be a slightly different approach.
Great, okay. What moisture levels in leaves is best for prescribed burns?
In our prescription, for our prescribed burns that the city does, our low end of the prescription is 80% fuel moisture with a target between 90 and 100, I think 95% or 100. But it really depends on the objectives of that particular prescribed burn. Most of our burns are done on water quality protection land in southern Travis County and North Hayes County. And the objectives of those burns are to control woody plant species. So our intent is actually to scorch or consume a lot of small juniper that are growing in those savanna areas. So we're looking for live fuel moistures in juniper leaves, at 100% or so. Our recent prescribed burns this summer, I think the live fuel moistures in junipers have been between 105 and 115%. And we've gotten good scorch without having a lot of flaring or torching of junipers.
Right. Next question. Are there any public funds available to help private landowners create shaded?
Ooh, that's a good question. That I'm not aware of any major grant programs for wildland fuel mitigation on private property. As the city and a lot of other governmental agencies, we're limited to how much resources we can spend on private property, which is why we're focused on the land we manage. I'm afraid I'm not aware of any right now, at least not in this area. Unfortunately, I think a lot of that stuff ends up being FEMA grants after a disaster. So that's a good question to ask your governmental reps, really.
Okay. And so there's a question about Native Americans and fire. How frequently do you think they would have burned?
I don't have a good answer for that. A lot of the records are anecdotal. There are good records from certain parts of the country about Native American groups using fire to attract game into an area, burning grasslands so that there's new growth there that tends to attract larger game animals for better hunting. There are some other suggestions of long-term management in certain parts of the country using fire on a more regular basis. But I feel like it would have been kind of something that would be done opportunistically, where in areas and places where it would be effective. That there may be some limited areas of the country where it was done on a cyclical basis for a long-term management goal.
Next question, how long has the fuel moisture monitoring program been going on and how has it impacted mitigation efforts?
Our records go back to 2007. So we're still doing this research now. So that's a very robust data set. The graph that you saw in the presentation was one that we used in a paper we published that was discussing our findings on fuel moisture levels in the winter and how the juniper were less responsive to moisture availability in the winter months than they were in the spring and summer months. So it didn't really matter how wet it was in the winter. The junipers always tended to be in this band between 80 and 100%. In the growing season, in the summer, the winter, or the summer and the spring growing season, the juniper reacted to availability of moisture much more strongly. That's what we saw in 2011. We didn't have those spring rains. The moisture wasn't there, and the juniper moistures plummeted instead of rising like they typically would. Much more sensitive to that in those periods of time. Our suspicion, or at least our thesis, was that had a lot to do with solar radiation, availability of light, longer growing periods, more energy for the plants to transpire, pump water in the spring and summer. Now, as far as impacting mitigation efforts, this information is shared with the local fire departments daily, and they do incorporate it as part of their daily wildfire risk assessments.
Is there a preferred or recommended ratio of ash juniper to hardwood?
Probably not a question for me. That'd be a question for one of the biologists in the BCP to answer that best. They'll be able to tell you what forest composition is most appropriate for endangered species habitat. And what we found is that applying shaded fuel breaks to the specifications that we've designed is not considered to remove that habitat. It's still functional habitat. So there are some arguments for higher ratio of hardwoods in the shaded fuel break, because those trees tend to have less density of leaves in the canopy, and so potentially less available energy if they did combust. They also lose their leaves in the winter, so that during those periods of times there would be less continuity in the leaves in the top of the canopy. But the shade that it provides, which reduces surface fuels, and the reduction of ladder fuels that we mechanically create with those shaded fuel breaks, I think is the best impact we got. It just keeps a fire that's on the ground to keep it on the ground so it can be suppressed. A fire that's already burning through the canopy is going to reduce in intensity when it comes to one of those shaded fuel breaks, because there's less density in the environment there. There's fewer ladder fuels. There's overall fewer BTUs available to burn in those areas.
And can you speak to concerns about releasing soil carbon with burning?
When we're burning, we are releasing the carbon that's stored in the vegetation that we are burning. When we burn grasslands, that vegetation is growing back and capturing carbon and rebuilding the carbon in the plant material that was burned off. So we are freeing up some carbon that's moving out of the area in our smoke plume, but we're also capturing more carbon with the vegetation that grows back there to replace it. There's been some research on the carbon budget in some of these grasslands where fires applied, and we're not releasing carbon that's stored in the soil, and we're not releasing any kind of fossil carbons to a measurable extent during these prescribed burns.
What is the expectation of the effect of climate change, particularly longer droughts, on fire risk in our area?
There's probably no doubt that climate change is going to impact the vegetation in this area inevitably, and the impact on fire occurrence and fire regime can follow the conditions of the vegetation, and then more extreme weather conditions we get. I don't know. I wish I had a crystal ball and I could tell you how climate change is going to affect everything about our environment here. Personally, my expectation is that if we start seeing more frequent and more severe droughts on a shorter cycle than we've seen historically, we might find ourselves in circumstances where fires could be more prevalent in the future. That's one possibility. And I think that's also an important reason for us to continue building resilience, not just in our woodlands, but also in our neighborhoods too. We haven't had a significant fire season in 10 years. So we could continue on that same course with infrequent droughts. Drought cycles might begin to accelerate in the future based on climate change. I think it's most important for us to be tracking that and seeing what the actual occurrence tells us.
All right. And what is the best way to get rid of the trimmed branches? Brush pile burning, chipping brush piles away from the trees.
Our first choice when we do a shaded fuel break is to remove the vegetation and process it in a way that it can be reused somewhere else. So we take the material out of these shaded fuel breaks whenever possible. We ship them and we take them to Hornsby, or we use them for some other purpose on the property. So we keep that material as close to home as possible and reuse it for soil restoration projects, erosion control, that type of thing, keep it on the property. If this is being done on private property, there is some advantage to rearranging the fuels by getting the lighter fuels into a different format, but just rearranging that material, you have to be very careful that it's not going to cause additional risk by being in piles that are easily ignited, or strips or berms someplace that could lead fire from one area to another, or become an attractive hazard for unintentional or intentional ignition. But just keep in mind that if you leave the material there, you haven't actually affected the available BTUs at that point. It's just a rearrangement of the structure. So yeah, our preference is to move it to another place and reuse it for something else. Second choice is to ship it into fine pieces and redistribute it in that same area so it can decompose quickly. And then our last choice is to scatter or then pile and burn that material.
And do you have an idea of the percentage of trees that died during the freeze last winter? And what impact does that have on fire probability?
I don't have a exact percentage on that. I can tell you that although we did have some tree mortality, a lot of our native species are pretty resilient to that type of freeze event. At least around town, what I'm seeing is a lot of the dead trees are exotics. We're seeing some dead exotics in our properties. We're seeing ice damage, broken trees that are dead from ice loading. Although those tend to be trees that are on the boundaries of the properties, those branches that are hanging out over unsupported at some type of transition from the forest to another landscape, they tend to break a lot. So it looks worse sometimes from the outside because a lot of the broken branches are on the edges of the property. But internally, we haven't seen enough tree mortality or structural damage to really warrant any additional fire concern. No, it didn't seem to make a fire problem.
What are some of the most common causes of wildfire in our area?
Texas Forest Service says 90% of the fires in Texas are human caused. So I think it's fair to say that human behavior causes most of the fires that we have around here. Now, there are thousands of fires in Texas annually. Most of them are suppressed rapidly or never amount to much. The major wildfires we had here in 2011, I think were all associated with power transmission one way or another. That seems to be one of the higher risks is, power distribution lines that can be impacted by a tree that tend to overload. I think that was a factor in 2011 as well. It was hot and dry and windy, and everybody was using their air conditioning full blast and putting a lot of load on the power grid that caused some equipment failures. And then the wind was blowing trees that had been weakened from several years of drought and knocking them into power lines. But most of the fires that occur in Texas are going to be roadside fires and things associated with power distribution or negligence, I think. We have some records of lightning fires on our properties, but as opposed to certain areas of the Western United States, we don't as frequently have those dry lightning storm events. A lot of times we have rain with our frontal passages and good rain with our thunderstorms. So a lot of times our big lightning events are associated with rainfall. And so we will see evidence of lightning, burning up single trees or small groups of trees. But it's not as common for a lightning strike to start a fire that amounts to much here. Now that, you know, that it would have been a big cause of fires historically, and lightning caused fires would have had a better chance of spreading through the area before we fragmented our landscape with roads and land use and started suppressing fires. The best lightning fire I've ever seen was up on the plateau in Lampasas area, and that actually was a significant fire legitimately from a lightning strike.
And are you aware of the Pellegrini study that determined soil carbon is being destroyed by frequent fires over time?
No, I'm not familiar with that.
And then next question, how do invasive trees affect our wildfire risk?
I'm not sure that there's enough invasive species in most of our BCP properties to really affect fire risk. We do have places with lots of privet and Chinaberry and that type of stuff, but those species are not as big of a fire risk as something like eucalyptus. So we do remove endangered species when we're doing fire mitigation work, but there's no particular endangered species that we consider to be an unusual fire risk.
All right, well, that's kind of the end of our questions. If anybody else has anything that they want to add, you can add it in the Q&A now. And then we also have some links to share, I believe, that we'll put in the chat. But
Luke,
yeah,
sorry to interrupt, Jaya. This is Johanna again. Luke, do you want to share that slide that has the links about the fire issues, and then we'll add the BCP links into the chat?
Yeah, you bet. These first links are local wildland fire information. Wildland, or the Wildfire Austin.hub there has got good mapping of fire vegetation, fire work that's been done. Firewise.org is a good place to prepare for more information about preparing your home. And the last one there is Wildland Fire Ready, Set, Go, about personal wildfire safety, so home protection as well as evacuation and personal safety.
all right, and we've got some other links in the chat as well for y'all. But I think that wraps up the presentation. Johanna, did you have anything else you wanted to add?
No, thank you so much, Luke. We really appreciate you taking the time to talk through this. And if y'all have any questions further about this, then, of course, it's a really important and very complicated topic. So I'm guessing there may be lots of questions in the future. Check out these links that we've included. And then I'm also putting a email address in the chat that you can always contact if you have questions about the BCP in general, any of those issues that we talked about today, or just, just BCP, how do you visit it, or what species are protected, any of that good stuff. We're happy to talk with y'all. In addition to, if you have ideas for other future presentations that you would like to see as part of this series, that would be helpful as well. So thanks again for taking time on this beautiful day. I know it would probably be fun to be outside, but you spent it in here with us, and we appreciate it. So take care, everybody, and we'll see you next time.